consists of first writing the block on drive 1, then reading it back to verify if it was written correctly. If it was not written correctly, if it was not written correctly, how do I know that it is not written correctly? I write to the desk and I read it back and I compare. What do I compare? Whatever I have written there or what else? How do you know that whatever you written is not good? You are writing to, I mean, you don't know if it's, I mean, the error might be due to the bad sector or something else, we don't know. Maybe there is some other problem. You write to the desk and you read it immediately back and you check your ECC field, right? Or you compare whatever you read to whatever you write. So it becomes slower to read and write, but it is more stable. So if if that data does not match whatever you read and whatever you write, then you continue this n times. Okay, you try it n times because it might be something transient, heart rate dependent, something dust or particle or whatever. If it doesn't work, then you need to go to your other disk and load the data and store it back on the original one. Okay, so that's the stable write. In the stable read, you read from the one of the first disk. Okay, if this yields an incorrect ECC, you keep trying. If you get something bad, then you have your second drive. Okay, you get your drive from the second one. So what happens if both of them are bad? I mean, if you read from this number 1, it is bad, and if you read this number 2, that one is bad too. That's a very, very low probability because not every day you get a bad sector. Okay, so if one of your disks are bad on one of the sectors, then that means that on the other drive, with a very, very high probability, you have your data safely. Okay. So if both of them are bad, then that means that you are a very, very unlucky person. In that case, you cannot do anything anyway. So you cannot keep your data stable all the time. In case your whole computer crashes, if there is a fire or if there is a flood, you cannot do anything. Okay, so this is the stable storage. How about time? So I am done with the hard disks, magnetic disks. I will talk about clock hardware. Then I will talk about keyboards and the screens, and maybe a little bit about X window system. Then I will skip rest of the chapter to go to the next chapter, which is deadlocks. Okay, so we are going to spend 1 week or 1.5 weeks on deadlocks. Let's talk about the clock hardware. Clocks are important on a computer. Why? Because using the clocks, okay, we maintain the time of the day. That's important. Why the time of the day is important? Because when we are creating files, okay, right? When we are creating files, when we are modifying files, we put that information on the file tables. That's important. Also, time of the day is important for the processes too, right? The process creation time is something important when you are doing the process scheduling. That one is important for the processes too. So maintaining time of the day is something important. And we can use clocks to measure the time that a process takes, that a process uses the CPU, accounting CPU usage, preventing process from running than allowed, and handling alarm system calls from user processes. If the user says that wake me up in 30 milliseconds, then I need to have a clock to do that. Okay. Also, we need watch log timers for parts of the system itself, and profiling, monitoring, statistic gathering, keeping a time is important. So how does the clock work on a computer? They have a crystal, okay, quartz crystal. If you keep this quartz crystal pressurized on a special equipment, then if you apply a voltage, okay, 0 to plus V, to this crystal. This crystal starts producing pulses at a given hertz. Maybe 3 megahertz or 5 megahertz, whatever. Okay. So this crystal is producing pulses, zeros and ones. You can think of it as a zeros and ones, and you get those pulses and you start counting them. Since this is producing at a fixed rate, those pulses, when you count them, that means that you keep your counter in this area. That means that this one is kind of a clock. It is measuring the number of pulses, and if each pulse is at a equal time difference from the previous pulse, that means you have a very precise clock running inside your computer, and this counter keeps the number of pulses. So when you copy this number to your holding register, that register becomes your time information for your computer. Okay. For Unix systems, this is the seconds that passes from January 1st, 1970. Okay. For Windows, I think this is the January 1st, 1984 or something. So they keep counting all those seconds that passed since that time. So this is the whole idea behind the clock hardware. It's not that complicated. It is not as complicated as the hard drives or the other type of stuff, but they are very important clock, and how we use them very important. So we are going to spend some time to understand how we deal with the clock problems. I guess I am out of time, so I will stop here, and on Monday we will continue. Any questions? Kaplama nerede? İmzalamayan var mı? Güzel bir yer.